So today is our second class of electrostatics, formula and important points. So this is the class 2, second class. So in the first class, I have discussed few formulas, around 5 or 6 formulas. So today we have the next formula. This formula is for electric field, formula number 7. So electric field or electric field intensity. The formula is electric field E is equal to K into Q by R square into R cap. Now this K means the normal 1 by 4 pi epsilon naught or 1 by 4 pi epsilon naught epsilon R, which we had discussed in Coulomb's law. This Q is the charge for which we are finding the electric field intensity. R is the distance of the point at which we are finding the electric field intensity, and R cap is the unit vector along R. So all of you know this formula, and you also know that this formula comes from that Coulomb's law, where we have force is equal to K into Q1 Q2 by R square R cap. Now for electric field intensity, by definition, that Q2 is 1, that is 1 coulomb, and for Q1, instead of Q1 we are writing capital Q. So this is the same formula. So this formula is derived from here. So this becomes K into Q by R square R cap. Right? So there is nothing difficult in this formula. Right? So if the charge is positive, then the electric field intensity will be in the direction from the charge Q to this. So if this is the point, electric field intensity will be along this direction, away from Q. And if the charge is negative, this Q is negative, then this electric field intensity will be along this direction, towards the charge minus Q. Clear? Remember that in the question sometimes they say find the electric field at a particular point. So you must understand that what they are asking is find the electric field intensity at that point. Okay? So the next formula we have is formula number 8, which is force F is equal to Q into E. Now what does this formula mean? It is for those situations where we have an electric field. There is an electric field for some charge. It is there in this space. And in this electric field or in this region, if we place a charge, so small q here, what is the force on this charge small q? Understood the situation? You have to be very careful about it. This formula is for that situation where in a particular region of space there exists an electric field. We are putting another charge small q there. Then this small charge will experience a force. That force is given by this equation. Okay? So this electric field is not due to this charge. This electric field is due to some other charge. So there may be a charge here, there may be a charge plate here. For some, the source of this electric field can be anything. We are not bothered about the source of this electric field. What we are bothered about? In this electric field, if we place a charge Q here, what will be the force on this charge, which is given by this formula. Clear? So when you see this formula, this situation should come to your mind automatically. So this is valid for that situation. Right? Okay. So next formula is formula number 9, which is the potential energy of a system which has two charges Q1 and Q2. So if in a space we have two charges, Q1 and Q2. So both of these together make our whole system. Then the potential energy of this system is given by this formula. Okay? Now, since this formula is very important, let me explain it further. See, in a space, empty space, there is no charge. So there is no electric field also here. So when we bring the first charge here, we do not have to do any work on it because there is no electric field, so there is no force on it, so we don't have to do any work on it. So for this first charge, there is no potential energy. Now, after we place this charge Q1 at this point, there will be electric field around this in the surrounding space, right? Now, when we bring the second charge Q2 from far away, say from infinity to say this point, we are bringing it. So there is an electric field here now due to Q1. So that means that Q2 charge will experience a force. So we have to do some work against that force to bring that Q2 to this place. Okay? So since we have done some work in bringing the charge Q2 from infinity to this place, so now this will have some potential energy. How much potential energy? The work done in bringing this Q2 charge from infinity to this point will be the potential energy of this charge Q2. Now since the potential energy of this is 0, so potential energy of the whole system is equal to the potential energy of this. That is the second charge that we brought. Okay? Now you see, go to point number 3. Potential due to a point charge. See, if you consider only this charge, say forget about this charge now, say if only this charge is there, the potential at this point will be, as per our point number 3, it will be 1 by 4 pi epsilon naught Q1 by R. Because this is at a distance of R. Okay? Now what is potential by definition? This is the work done in bringing a unit positive charge from infinity to this point. Remember? Work done in bringing a unit positive charge from infinity to this point. So that is the potential. Now, if the work done in bringing 1 unit of charge, 1 coulomb of charge is this much, so what will be the work done in bringing Q2 coulomb of charge? So that multiplied by Q2. So this formula, you can also write it like this. Potential due to Q1 at this point multiplied by charge Q2. Because you see from point 3, this part is V, potential at this point due to this charge Q1. Understood? Many students get confused on this point that there are two charges. So I am taking the potential energy of this charge and saying this is the potential energy of the whole system. How come? Why we are not adding the potential energy of Q1? I have answered it already, but again I repeat because this is very confusing. See, when you bring the first charge in an empty space, in an empty region, no work is done. So the potential energy of the first charge that you bring here is 0. If it is Q1, no work is done in bringing Q1, so potential energy of Q1 is 0. Only when you bring the second charge Q2, some work has to be done, so that will have some potential energy. So that potential energy plus this 0 makes the potential energy of the whole system. Clear? In some situations, when we know the potential at a particular point, and we have to find the potential energy of another charge at that point, we simply multiply that charge with the potential, we get the potential energy of that charge. Clear? Okay. From here follows the next point, point number 10. It says, for a system of more than 2 charges, we add the potential energies of all charges. So instead of 2 charges, if we have 3 charges, okay? So let me rub this off first. Say if we have 3 charges, so what will be the potential energy of this system? So see, in this empty region, we brought the first charge, no work is done, so potential energy of Q1 is 0, right? Now we brought the second charge from this way, from infinity, from anywhere, from infinity. So since some work has been done, as I have explained before, so this will have some potential energy. Okay? Now in this region, there are 2 charges. Say we have brought a third charge Q3. When we are bringing the third charge Q3, there is an electric field here due to these charges Q1 and Q2. At every point there will be a potential due to Q1 and Q2. So against those electric fields, we have to do some work to bring Q3 to this point. Okay? So this will also have some potential energy. So this potential energy of this, if I call it U1, this will be 0. This was the first charge we have brought. Potential energy of this, if I call it U2. Potential energy of this, if I call it U3. Then total potential energy of the system U will be U1 plus U2 plus U3. U1 plus U2 plus U3. Clear? If we bring a force charge here, say Q4, if I call it. Now there is an electric field here due to these 3 charges. So there will be electric field here, there is an electric potential at every point. So against that electric field, we have to do some work. So this will have some potential energy. So if you call it U4, now the potential energy of the whole system will be this plus U4. That means the potential energy of a system is equal to sum of the potential energies of each charge. So this way you can keep on extending it. If there are n charges, n plus n. Okay. The next important formula for us is formula number 11, which is Gauss's law, which you all know is very important.